everyone, welcome back to Grade Up. In our last video lecture, we have discussed some previous year questions on SQL queries. Till now we have completed database design, relational algebra and SQL queries. Let us start with one more new topic in database management system, that is file organization and indexing. You are not having, I have discussed about indexing in our first video. A very small discussion has been done on indexing. Now in this particular video lecture, we will study indexing in detail and how indexing is implemented and why we are using indexing. So the basic rule which I follow before studying a particular topic is, I really wanted to know why I am going to study this particular topic, and this is the basic thing which you should follow. You should know why we are going to study this particular topic. So guys, if you remember, I told you we are using indexing to decrease our access cost of data. That is, if we want to access our data from hard disk, then if I want to decrease the cost of accessing the data, then I am going to use indexing for this purpose. Now let us start how we are going to use indexing for decreasing the access cost of accessing the data. Let us start. First of all, we'll start with the basics. Let us see how database is organized. See, we are having some database. Then there is some files in that particular database, F1, F2, F3. These files are known as tables in our database system. These files are stored in blocks. You know the memory is divided in the blocks. The basic memory which we are having, or the disk, is divided in the form of blocks, and these blocks are storing files. These blocks again storing records, and records, you know the basics, the tuples in our tables. So what we can say about organization of our database? First of all, it is having some records. Records are stored in blocks, and these blocks are storing files, and these files are part of our database. In this manner, our database is organized. Let us see how we are going to store the records in our blocks. See this particular part, that how files are getting stored into the blocks. This is not at our end. Definitely we are not going to deal with this thing, because operating system or memory management system, whatever we are having in our systems, will take care of the thing how to divide the memory into blocks and how to store the files in those blocks. The basic thing which we are going to do is storing of records into the blocks. So let us see how we are going to store the records into the blocks. For this purpose, we are going to study records organization. So let us start with records organization. See, suppose we are having one block of memory B1. This is another block of memory B2. Same thing is here. Guys, don't refer to the thing. Don't see whatever I have written on the screen. Just listen to me. You will get the clarity. Suppose this block size is 100 bytes. Okay? And the record which you want to store is of 30 bytes. So, if you get a rough idea, you can store around 3 records in a particular block. See, I have stored something like R1, record R1, record R2, record R3. This is taking 30 bytes. Again, this is taking 30 bytes. Again, it is going to take 30 bytes. We are left with this 10 byte space. I want to store one more record. Is it allowed to store 30 bytes of data into 10 bytes of memory? Is it allowed? No. So there may be one case, like I can divide this R1 into parts, that is 10 byte of record 4 I can store here, and 20 bytes of record 4 I can store here. So what I am doing that I am storing single record into more than one block to save the memory. I have stored the 10 bytes of R4 in the first block and 20 bytes of record R4 in the second block. So what I can say about this thing, my record is spent. That is, it is distributed or divided into 2 blocks. Spent means distributed, divided. Okay. So this type of organization, when you allow a record to store into more than one memory block, it is known as spanned organization for a record. But see one more case where you are going to store R1, R2, R3. But you are left with 10 bytes of space, but you don't want to store your records into more than one block. You just want to store it into a single block. You are not desired to store in such a way that if you want to refer that record, then you have to refer 2 blocks. So what we are going to do, I will leave this 10 bytes of space as it is and store this R4 into new block. Again 30 bytes will be assigned to this particular record in block B2. So this type of organization is known as unspanned because you are not allowing your record to be distributed into more than one block. What can I say about this type of organization is there is a wastage of memory. For each and every block, you will see that 10 byte of memory is wasted, and this behavior is known as fragmentation. Guys, in each and every block, what we are going to have, one more thing is block header. Each block for memory is going to maintain a block header, and this block header will store the pointers for records which are stored in that particular block, so that at the time of accessing, it became very easy to access those blocks. Each and every block is going to have block header. So what we can say about record organization? Record organization can be done in 2 ways: spanned organization, unspanned organization. Unspanned organization, when you don't allow your record to be splitted and divided in such a way that you are storing it in 2 blocks. And spanned organization, when you are storing a part of record in one block and remaining part in other block. And unspanned organization suffers from fragmentation. That's all about records organization. Let us move towards next thing in this particular topic, that is block factor. What block factor represents? Block factor represents maximum possible records per block. That is number of records you can store in a particular block on max. That is maximum number of records you can store in a single block. How you are going to calculate this thing? Suppose you are having a block of size B bytes and record of size R byte and block header with size H byte. So block factor will be memory which you are left when you remove the memory which is allocated for block header. You have removed the memory which is allocated to block header from the block size and then divided with record size. In last example, what we have, block size was 100. Let us say the block header size was there 0 byte and record size was 30. So what we have, 3. When you were doing unspanned organization, that you were not allowing your record to be split into 2 blocks, then it was 3. You have seen we can store only 3 records, and for unspanned organization it would be 100 divided by 3, that is something like 3.33. That is some part of the next record can be stored in this particular block. So this is the formula for calculating block factor for a particular block. Let us see the next thing, indexing. We have discussed the basics on our indexing and file organization. Let us see why we really need indexing. See, it is given that you are having a relation. Suppose you are having a relation employee with 3 attributes: EID, ENAME and grade. And it is already mentioned that this particular table is having around 1 lakh of records. Then the size of this particular table is quite large. You can clearly see. Suppose this particular table is occupying n secondary memory blocks. Then you want to execute this query on the given table. The query is saying select star from employees where EID is equals to X. That is, you want to select the details of employee with employee ID X. So for executing this particular query, you know the basic rule. The basic rule of execution is whatever data you want to execute, that should be placed in main memory. That is, whatever you want to execute, or you want to perform some operation on some data, that data should be present in our main memory. So if you want to bring this whole data, if you want to bring this data into main memory, you have to shift these n memory blocks into main memory. Suppose you want to execute this query, then you have to bring all these n memory blocks to your main memory. This would be very time consuming, cost will be very high. For accessing a single tuple, you have to bring the whole data. Then the time which it will be going to take is order of n. Yes, you can say if the data is sorted, I can apply binary search. Yes, you can apply binary search. Then also you are going to have log to n time. This is quite a large time to execute this much small query. If you are taking this much time for executing this type of simple query, then it is not a good idea. It is not allowed. So we are using indexing so that this particular time can be saved, or we can improve the way of accessing the data. For this purpose, we are using indexing. Now let us actually start with indexing. What actually indexing is? It is given that index for a particular relation will contain two things. Whenever in indexing, what you are going to do, you are going to build an index for a given table. Suppose you are given a relation R, then for applying indexing, you are going to build an index on it. The index for that particular table is going to contain two things, key value and pointer. Let us take it as the simple thing. Up to now, we will discuss what this pointer is and what this key value is. Then if you want to calculate the block factor for an index file, what is that block factor is going to contain. Till now you have discussed block factor for a database file. What it was? B minus H by R. That is the block size which you are having for free and the record size. Here the record size in the index table would be key value size plus pointer size. Then index block factor for index file will be B minus H upon K plus P. Here record size is K plus P. In this manner you can calculate block factor for index file. One more thing which I want to tell you, your relation R will going to have so many tuples. The record size will be quite large over there. Suppose you are having 5 or 6 attributes, then you have to sum all those attributes for calculating the record size. The record size will be very large. But here in index, what you are going to have only two things. One is key value and second thing is pointer. Then the size of record in a particular index file will be very small as compared to our actual table. So what we can say, block factor for index file will be more than block factor for our database file, because record size in our database file is quite large and record size in index file is quite less. Let us move towards next topic, that is type of index. How we are going to build the index? There are basically two types of index, dense index and sparse index. First of all, let us start with dense index. Till now you know whatever we are going to store in our index relation, what we are going to store is, one thing is key value, second thing is pointer. What this pointer is going to store, you can see now, this pointer will store our address to the memory block of our given table. Suppose we are having some relation R with some attribute set, where I am using this A as our key attribute for deriving our index relation. Suppose this R is stored in 4 memory blocks, B1, B2, B3 and B4. I want to build index table for this particular relation. I have already told you that block factor for an index file will be more than block factor for the database file. Here this block is storing 2 records, so we can say the block factor here is 2, but block factor here will be 4. Okay, so how we are gonna do for we will store a particular key and then pointer to that particular key. See, I have stored 4 and pointer to that 4, 6 again, then pointer to that 6 key, 8 then pointer. The basic idea with dense index is you are going to store each and every key in your index file. That is, there exists an entry in your index file for each and every database record. You will see for this record I am having 1 entry, for this record I am having 1 entry. In this manner I will store entry for each and every record and then pointer correspondingly. Okay, this is the idea with our dense indexing. Let us move towards sparse index. The basic idea with dense index was you are going to store an entry in your index file for each and every database record. But this was quite, then the index which you are going to have using dense index will be quite large because you are storing each and every key value. But with the sparse index, the basic idea is you are going to store entry for each and every memory block. Now you are going to give the entry for one block, for this block, 1 entry, and for this block 1 entry. You are not going to store each and every record. What you are going to store? The pointer for each and every block. So if you observe in our last example, the index file was containing 2 blocks and here the index file is containing only 1 block. So the size correspondingly decrease, and when you are going to access your database, then there you have to access 2 blocks. Now you have to access 1 block. Simple. How we are going to do? Suppose you want to access some data 4, then you will go in this particular table, index table. You will traverse like, is 4 there? No. After 2 it is 6. Then data which I want to access is 4 can be accessed through this 2 pointer. I will go to this particular block and I will access the data in such manner. Is 2 there? Is 2 there? Is 4 there? Yes. Is 4 there? I can access this record. So I can clearly see the cost is comparatively decreased. Suppose you are not using indexing, then the cost for accessing will be, you have to bring this whole table in your main memory. The cost will be 4 blocks. Now you are using sparse index and you want to access your database. Then the cost will be like, first of all you have to access this particular block, 1 block. Then using this pointer you are going to access 1 more block plus 1 block. Cost will be 2 block. You can clearly see the cost is reduced to half, and we are taking a very small example. If we think about the bigger examples, then it would decrease a lot. It will decrease our accessing cost very, that is the cost will be decreased very high. That is, we are going to save so much time. This is the reason why we are using indexing. So basically there are 2 types of index, dense and sparse. In dense index, you are going to keep entry in your index relation for each and every record. In sparse index, you are going to keep entries only for blocks of memory. Now, let us discuss types of index on the basis of keys. You know, in index relation, we are going to store key plus pointer. These index can also be divided into subparts on the basis of this key, and these pointers are memory block pointers. Suppose you are having some relation R, you have chosen A as key. If A is a candidate key and a ordered field, then the index which you are going to build is primary index. You can clearly see A is ordered and it is a candidate key because all the records are distinct. When you are going to build a particular index on this relation, see what you are going to have. You are just going to have 2, 6, 10. See, while building index, you can have two things. Either you can build a dense index, either you can build a sparse index. But one thing you can keep in your mind, building dense index will be hectic or will take more cost because you are going to store data for each and every key. But it is not required. You can build sparse index also. That is, you are going to have pointers for each and every memory block, not for each and every key. I have B1 block, B2 block and B3 block. I'll use key 2 and will maintain a pointer towards B1 block. I'll use key 6 and maintain a pointer towards B2 block. I'll use key 10 and maintain a pointer towards B3 block. In this manner, I have built the index. Suppose this particular table is of size around 10,000 tuples. Then you are going to have so many blocks in your index file also. Suppose you are having here around 50 blocks. So if you want to access your data using this primary index, what you are going to access? First of all, you will access these 50 blocks, then one more block for actual access of data. Then you are going to access 51 blocks. But still, I still want to reduce this particular cost. What I am gonna do? I will apply indexing over the index table. Now I have applied the indexing on our relation. I am gonna apply indexing on this index table. Again, I will follow the same procedure. Again, I will apply the indexing. Then next index, I am gonna build key for this particular index block and pointer to this index block. And I will apply this indexing till the time a particular index is obtained where only one memory block exists. This particular idea of building index for index tables are known as multi-level index. Let us discuss the cost. Suppose you have built index on your index tables and in such manner you have built m indexes. That is m levels of index. Then the cost of accessing would be m plus 1 because you are going to access one block from each index level and one for actual accessing of data from relation R. See, in previous case, what you have to access all the blocks of table, but now you are getting such a less cost. So what we can say, we have improved our work and we have saved a lot of time by using indexing and multi-indexing concept. Let us move towards next type of index on the basis of key. Next type of index is clustering index, where search key, your key is a ordered field that is sorted data but a non-key value. So you can clearly see here repetition of data is allowed. Then for this particular type of indexing, you can build only sparse index. This one key value is known as cluster. That is 2 is representing one cluster, 3 is representing one cluster and 4 is representing another cluster. How you are going to build your index? You will maintain a pointer for each and every cluster, that is starting of each and every cluster. Here you will maintain a pointer for 2 for its starting, 3 again starting, 4 again starting. Then suppose you want to access a cluster 3. What you are going to do? You will go to index file, then access that pointer you reached here. Now you have accessed 3. Then a particular pointer from that block in your table is maintained for accessing another part of that cluster. In this manner, you are going to access your data. The same multi-level indexing concept is applied here also. So what you can say about clustering index? Clustering index will be built on a key value which is ordered but which is not a candidate key. Here key value is not a candidate key but it is a ordered field. You are going to build index on the basis of cluster. For each and every cluster, you are going to keep an entry in your index table, and the pointer will point to the starting of that cluster. In this manner, clustering index is built. Let us move towards next thing, that is secondary index. See, we have discussed two indexes till now, primary index and clustered index. Both were on ordered field. But if you are going to develop an index which is not on a ordered field, that is field is not sorted, then how we are gonna do? The index which we are going to build on non-ordered field, unordered field, will be a dense index. The first level will be dense index because key fields are not ordered. You cannot access, like you will start with 2 and go to 4, 6, 7. You cannot access, you cannot specify the sequence in which you can get the data. So you cannot specify the sequence, and you cannot use sparse index here. What we are going to do, we will maintain entry for each and every key value and pointer to that particular entry. See, here we are having the data from starting to 2 until 9, and I have maintained all the key values in our index file and maintained the pointers to them. The basic thing is, after first level of index, you can apply sparse indexing. There is no need of applying dense indexing after this particular level, because now you are having sorted data. For accessing 4, what you can do? You will go here, here is 2 key and here is 6. What you will do? You will go to here, this particular block, and start traversing. Is this 2, 2, 2? Here you got 4, you want to access 4, then you can clearly access from that pointer. This is the idea with secondary index. So, before I summarize all the indexes on the basis of type of key which we are using, there are basically 3 types of indexes: primary, clustered and secondary index. Primary index, when you are going to build your index on the key value, that is the key value is candidate key and a ordered field. When you are going to build index on an ordered field but the value is not a candidate key, then you are going to have clustered index. But when the key value is not ordered, then we are going to get the secondary index. The secondary index should be dense index for the first level of indexing. That was all about indexing. Let us discuss an example on our indexing. Consider the data following Consider the following data regarding storage details of file in the system. Here we are provided with some data. See, block size is mentioned as 1024 bytes, key size is 6 byte, pointer size is 12 byte and record size is 32 bytes. It is asked that what is the level of indexing is required to generate the primary index, and it is mentioned that first level of index is sparse. I have mentioned you that you can use both dense or sparse index in primary indexing. So here block size is 1024 bytes, key size 6 bytes, pointer size 12 and record size is 32 bytes, and level of indexing is asked. We'll start one by one things. So first of all, before starting, I should calculate block factor for database file. What is the block factor for database file? B minus H upon R. Guys, it is not mentioned here whether you are using spanned organization or unspanned organization. And when it is not mentioned, by default you are going to take unspanned organization. Here block size is 1024 bytes and header size is 0. And record size is 32 bytes. So block factor for database file will be 32. Let us calculate block factor for our index file. By using block factor, we can get a clear idea how many blocks we are using to store a particular file. What is the formula for our block factor for index file? B minus H upon R, and record size in our index file is key value plus record pointer value. Then it will be 1024 minus 0 upon 18. 12 plus 6 is 18, and the value would be, tell me after calculating the value. Yes, it is 56.2. 7 something, and it would be 56. Okay. Now, if you observe, we are having block factor for database file and block factor for index file. One more thing I have already mentioned you, that block factor for index file will always be greater because value which we are going to store is quite less for a record. Let us see what is next we need to calculate. Now we know how much a particular block can contain for database file. So let us calculate the number of blocks in our database file. For database file, number of blocks for database file will be number of records divided by block factor of record. That is how much record you want to store and what is the number of records you can store in a particular block. If you divide both of these things, you can clearly get number of blocks for database file. What we are having, records are 65536 and block factor is 32. Then we are going to have, calculate it on your end. I am calculating it on my end. Calculate, it will be 2048. Now read the question again. It is clearly mentioned that first level of index is sparse index. So in sparse index, what you are going to do? You are going to build or store the data for each and every memory block, not for each and every record. So number of blocks which is required for first level of index will be number of memory block for database divided by block size for index, block factor of index. What you are going to have here? Number of memory blocks are 2048 and block factor for index is, tell me, 56. Calculate it on your end. I am calculating it. Tell me the answer. Yes, it is 36.57. What we are going to take? 36 or 37? Yes, 37, because these 57, that is some records are still remaining to be stored. You cannot manage them in these 36 blocks. You required one more block on extra. So in our first level of index, we are having 37 blocks. And according to the concept of multi-level indexing, what we have studied, we will apply indexing on our index file till the time we got one block in our index file. So again I will apply indexing on this particular level. Number of blocks in second level of index, what we are going to have? Number of blocks in first level divided by block factor of index. Then what we are going to have? 37 divided by, what is the block factor for index? 56. Then what we are going to have? Something in point, let us say 1. So second level of index is having only one block. Is further multi-level indexing, is further indexing is required? No, we need not require further level of indexing. So the level of indexing here is, tell me, 2. We will apply indexing till the time our index is going to have only one memory block. We have clearly observed this thing with an example. In such type of question, what you are going to do? First of all, calculate the block factor for each index file and database file. Then according to requirement, whether you required sparse index or dense index, calculate the number of blocks in your first level index. Then apply indexing further by using the given data. So now you are clear with this type of example. In this particular question, we are using indexing in such a way that 2 levels of indexing are built. So guys, this was all about indexing. We have discussed all the types of indexes and we have discussed a good example on multi-level indexing. In this manner, we are going to reduce the cost for accessing our database. So in our next video lecture, we are going to study multi-level indexing when we are going to use it dynamically. We have studied till now static multi-level of indexing and the improvements in this particular multi-level of indexing. So thank you very much for watching this video. Stay tuned and updated for more videos. Thank you again.